I'm going to talk about profiling RSpec builds, and my name is Mike Wheeler. I am co-founder and CTO at G2 Crowd. If you haven't heard of us, we are a Chicago company. We are a review site for business software and services. And before I launch into profiling RSpec, I wanted to talk really quickly. We're doing hurricane relief work at G2 Crowd right now. If you go to this URL and take 7 to 10 minutes and write a review, we will donate $10 to the Red Cross in your name to help benefit the victims of the hurricanes in the southern states. So just something to keep, when you have a moment today, when you have time later, please take the time to go to this link and follow along. So RSpec, I had a problem a couple years ago. My specs were getting slow, my app was getting bigger, my test suite was really big, and I needed to improve my build time so that I could be productive. So I started digging around, looking for solutions that would help tell me what was going on. And what I found was that it's very easy to find a solution that could tell me what is my slowest spec. And they'll take my specs and they'll stack rank them slowest to fastest, and then I guess you're supposed to start at the top and go down, and then your suite will be faster. But I found this is a very, very not optimal way to work, because I already know what my slowest tests are, and they're all in the features folder, and they're all booting up a browser and running JavaScript. And there's a reason that they're that slow, and it's very, very difficult to try to make them faster. So I can have like an 8-second spec, I can spend 3 hours on it, and now I have a 4-second spec, and I didn't really do anything. So what I really wanted to know was, where should I be spending my time to optimize my test suite? So toward that end, I built RSpectacles. RSpectacles is a formatter for RSpec that visualizes your test suite as a D3 partition graph. So if you haven't seen this before, basically every arc is representing a file, and its size is representing how long it took to run that file's specs. And then we group them by directories. So you've seen this before. You have a gem, you install the gem, you configure RSpec to tell it which formatter you want it to use. You start up a server, which will be running and then doing the visualization. And now you can run your specs pointing it at that server. So I have a examples suite right here that demonstrates here's the controller specs in this green region, here's the feature specs over here, and here's the model specs over here. So pretty much what you'd expect. The feature specs take a lot of time, but there's only a handful of actual specs. When you look down, and these outermost layers are actually the examples inside the file. And so what's really cool, and what I've really benefited from using this tool, we use it in production, is that I already knew about this one, but I didn't realize that maybe this model spec over here had 20 different examples that were running about just not quite as fast as they should have run. They were significantly slower than most model tests. But there's no way that by the time I got through the stack rank and got to this list of specs, it's way down at the bottom. So something like this happens all the time, and you have like a before block or a factory that's slow. You make one tweak to your code base, and suddenly all of that just gets sucked right out. And this thing it's taking up that much time, ends up taking that much time. So that's RSpectacles. That's what I'm able to do with it. You can go find it on Ruby Gems, and also don't forget g2crowd.com/WindyCityRails. Thank you.
As mentioned, my name is Hillel Wayne. I currently work for a company called eSpark Learning. We're hiring. And I'm giving a talk called Intro to Ruby. So, first important question. What is Ruby? Like, we named our programming language after it, so what is it? I kind of find it weird that a lot of people don't know very much about it because, again, like, we say the word every day, but if I asked you what is Ruby, most of you probably couldn't answer very well. So, Ruby is a red sapphire. This is actually the definition of what a ruby is. If a sapphire is red, it is a ruby. Otherwise, it's a sapphire. Note that sapphires can also be like green or orange or pink, except if a sapphire is pink, there's really serious controversies in the gemologist world over whether the sapphire is a pink sapphire or a pink ruby. If you thought Emacs vs. Vim was serious, you know nothing. Okay, so what is sapphire? Because now we've just pushed the question one step back. If a ruby is a red sapphire, what is a sapphire? So there's this element called corundum. It is a kind of mineral that is made of aluminum and oxygen. And for the most part, we just blow it up and take all of the aluminum out of it. It's not even a very great source of aluminum because like bauxite is better. But it turns out that sometimes corundum has chromium in it. And if it has chromium in it, it turns red. And then you get a ruby. Then you can cut the ruby down to make an actual gemstone. So where do people do this? Ruby in general is found in Burma/Myanmar, the Nogok area. That's where most of the corundum is mined. Also, fun fact about the word corundum, it's, I think, Tamil. It comes from the Tamil word for ruby. So ruby comes from ruby. In any case, while most of the gems that are mined, the best quality gems are found in Burma/Myanmar, as you can tell from the fact I'm calling it Burma/Myanmar, it's kind of going through a serious crisis, aka genocide. And since the 2008, the United States has banned all imports of anything that has passed through Myanmar/Burma. So instead, we get most of our gemstones through science. Ruby is actually the first gemstone we figured out how to synthesize scientifically. It was done by this guy, the one that starts with the V. I am not pronouncing that. And it's called essentially the magic shell method. You pour a bunch of really hot molten ruby onto a stone, the whatchamacallit, the corundum, and then as it cools, you spin it really fast, and you eventually get a little bowl. That's the ruby over there. In fact, this method has been discovered around 1895 or so, so within 10 years of him figuring it out, he was able to create maybe about 10,000 pounds of rubies a year. That's why the ruby market slide a bit and why they try to convince you that it has to be natural to count. That's complete garbage. It was mostly been replaced by the I'm not pronouncing that either method, which is essentially using like a caramel apple. You dip the apple into the molten ruby, the molten corundum, and you pull it out very slowly. And as it solidifies, it creates a single giant crystal. This can be done with rubies, but it's more often done with silicon. That's where most silicon wafers come from. Third method is called, I can pronounce that, fluke process. And this is aka the rock candy method. You create a solution of sugar, ruby, whatever, and then as it slowly crystallizes, you get really big stones like this. Time? Oh, whatever. So why do we care? Ruby's actually one of the less useful gemstones because, like, if you're going to synthesize something, might as well make it diamond, right? So it's kind of pretty, but it's not that useful for very much, except lasers. Around 1950, a couple of scientists realized that because of the crystal-like patterns in ruby, if you shine a light just right, you can actually get a very narrow wavelength. And this created what's called ruby lasers, the very first lasers in the visible spectrum. In fact, this is actually the very first laser ever built. And in 2010, it was taken out and hooked up, and it still runs quite fine. Even so, historically this is important, but most lasers these days don't use ruby rods. Even though they're cheap, they're also not that powerful. Green and like bauxite and such are actually way more popular. So why ruby? Main question. I actually did some research on this, and the reason we call ruby ruby is because Mats was trying to find a name, and one of his coworkers was like, hey, Ruby's my birth month. And he's like, yeah, sure, we'll call it Ruby. That's literally the reason. He came up with like the Perl explanation post facto, but it was literally he liked the name and a coworker liked it too. So in conclusion, I hate Keynote. I did this PowerPoint in Keynote. Keynote was a miserable experience. I'm never using it again, and I am free. Yes.
So as I said, I'm a software engineer at Collective Idea. So let's talk about Git. Git is a powerful collaborative version control tool, and many folks, it's hard to imagine doing any active development without it. So you've got everyday Git, commands that you use regularly throughout your day, and then you've got oh shit Git, which are commands that you hopefully use infrequently, but you need very much when things go horribly, horribly, horribly wrong. And you hope these magical commands can fix it. And then there is git blame. And this is the command that tells you who wrote what and when. So let's take a minute to talk about blame. The word blame has a very negative connotation. The act of blaming assigns responsibility to a person for a specific fault or wrong. And so blaming someone for a code they wrote in the past can be very detrimental to their growth and confidence as a developer. Blaming and finger pointing can also prevent an environment conducive to mentorship and feedback. So even if typing git blame is second nature, the intent of the word is ignored, there's still that nagging negativity in its use. So while the command is technically true, I'd rather use another word or phrase. Thankfully, Git offers a built-in solution. Git alias is a wonderful command that allows you to alias any Git command to something else. So I use it a lot to shorten and abbreviate commands so I don't have to type as much. But I've also created and used and improved on several different Git aliases to get around my dislike of using git blame. At first, I ironically flipped blame directly to praise as a way to get myself into more of a positive mindset. This worked for a while, but eventually I fell back into using blame whenever a particular line of code stumped me into disbelief. So for those times that neither praise or blame sufficed, I created whodunit. After all, git blame is really there to tell you who did it, and so why not make an alias to do just that? And then for those times that you get what they were doing, but they're confused about why they did it that way, you've got get why though. And sometimes you're just simply baffled. And these are the code snippets for me that boggle my mind once I figure them out. But I reserve this WAT for code solutions that are over-engineered or super clever, but you can't help but be baffled and impressed by the ingenuity that it does what it's supposed to do, and well. And finally, you have you what mate. I added this one as a joke, but there are those snippets that bring out the feeling of frustration or anger, like you look at the code and you're just like, why did you just do this? And this usually comes out because it goes against your better judgment or how you were taught or how you personally feel that piece of code should have been written. And while historically you what mate is a meme that invokes a fighting stance, I hope it starts a productive conversation about your differences in opinion. Thank you.
Hi, Windy Delays. Good afternoon. A little bit about me. My name is Hiroshi Yokino from Japan, server-side web developer, especially using Ruby on Rails and remote worker. Today, I'm talking about how remote work is valuable. Wow. Oh my gosh. Okay. いけるかな? Okay. Remote work is very convenient, so we can make hours to spend with our family, easy to take a rest, even may take a nap. These are what we always hear, good aspects for life. But I think remote work also has good aspect for work, and I'm talking about that. There are 2 points. First point is encouragement of self-management. It is difficult for our boss to remotely manage us. We must think and act on our own. We should have a bird's eye view, look around the entire project, find what we should do, and decide to do next. Also, we have to do something in need to proceed the project, even if it is not related to development, such as persuasion to someone, meeting with product owners, approval, etc. It seems beyond the role as a developer, but it is necessary to make a good software. That is, this working style requires us to consider the project more, and it makes our insight widespread beyond just one developer. As a result, we can enhance our abilities, and it leads to making a good software. Second point is working discretionary, which means we are not interrupted while working. If we work at the same place like office, we may make a conversation, may ask something to each other anytime. It would disturb us even when we are concentrating on work, especially coding. We can rarely concentrate on coding beyond we expected. Once it comes, we can write so elegant code so quickly. We can do anything. So no one wants to stop such a special time, right? So if you work remotely, you can keep the time because you can work discretionary. Any obstacles are not around you. That is, this working style encourages us to work productively, and it also leads to making a good software. These 2 points are a good aspect for work. Let me introduce my company's case to prove it. In my company, all staffs and business partners work remotely, and it has been over a decade since my company adopted this working style. This is Japan map. All developers live in a different place they like. We work discretionary based on self-management. No one waits for the instruction from our boss. We always find and deal with issues by ourselves. Actually, we can accomplish valuable works and get a lot of appreciation from our clients. This is one of the proof that remote work encourages us to work productively. By the way, do business together? We have a lot of experiences about remote work, so I believe we can collaborate even across the Pacific Ocean. Of course, we both have different culture, so we have a different way of thinking, coding, solving problems, etc. It seems difficult to work with. However, if we do business together, it might be the chance to run such a different way, and it is so meaningful. Don't you think so? So feel free to contact me if you like it. I'm looking forward to doing business together. Conclusion. Remote work is not only convenient for life, but also productive for work. I hope this working style will spread more all over the world because I believe it can influence developers to make better software. That's all. Thank you for your time.
So my name is Ifat Rabon. I'm a Ruby on Rails developer at Launchpad Lab. We build custom web applications for our clients. Today I'd like to talk to you a little bit about the concept of build or buy. So I imagine most of you in this room have heard of this before, but maybe we traditionally think about it at an executive level. For instance, a CTO who's considering whether to buy a software solution or hire developers to build it in-house. However, I'd like to argue that you can really take this approach all the way down to the developer level, for instance, when you're getting ready to start a new feature in your application. And even the case with when what you're buying might actually be free, like an open source Ruby gem. So I want to walk you through a couple of factors that I think you should consider, and this really can go on throughout your career as a developer at all experiences, from junior to more senior experience. You can kind of work through these factors as you get ready to build a new feature and decide whether to build it or buy it. The first factor is time. I think most of us find this a pretty obvious factor. Building, oh, apologies, my emojis are all screwed up. All right, this is why sometimes when you try new technologies, it doesn't always work. Go live time. But that's a builder, that's a buyer. With time, obviously building can be pretty time intensive. You've got to design your approach, code it, test it. Maybe you'd like someone to review it. You're gonna refactor. It's an iterative process. It took me a long time just to say all that. With gems, however, they're known for being easy to get up and running very quickly. You install the gem, maybe you've got an initializer or you got to run migration, but you can pretty much get to using the gems methods right away. I would point out though that if you come to a point where the gem no longer meets your application needs, suddenly you can be spending a lot of time trying to untangle a gem. For instance, if you've got a bunch of earlier migrations or a lot of data that you now need to move around, or if you sprinkled that gem throughout your entire application, it could take you some time to unravel that. On a related note is the idea of complexity. Of course, a more complex feature would take longer to build. But instead of just thinking about complexity, I want you to take it a step further and ask yourself, is this feature complex, but is it common? A good example is security. And authentication and session management can be pretty complex, but a lot of web apps use it. It's a very common feature. There's just some nice libraries out there, Devise, I'm sure many people here have used. Someone's already gone through the work of abstracting it and battle testing it, and people have had a lot of success with it. Let someone else do the work for you. On the flip side, if your feature is complex, but pretty unique to your app, there may not be a library available for use, and you've got to default to building it. For simpler features, they could be common or not. There could be libraries available for them. But here's where your due diligence on a gem would be really important. You have to look out for a couple things. One, that your gem doesn't start to overreach its boundaries inside of your app, which I'll talk on the next slide. Or two, that it doesn't lead to unexpected behavior. An example of that is a feature like archiving that several people probably have used at some time. There's some nice gems out there that do a soft delete function. But some of those gems are actually overriding Active Record's destroy method. That's unexpected behavior. Someone new to the code base or not familiar with the gem might not be aware of that. So I mentioned flexibility and customization is another important factor. If this feature is going to be really unique and need a lot of customization, building gives you that full control from start to finish. You get to make all the decisions along the way. On the flip side, gems are generally very abstracted. They've kind of thought of a lot of use cases. On the plus side, they've also thought of a lot of edge cases. Sometimes though with gems, and again, some due diligence here is some gems are really good at leaving the gem to be very configurable. There are a lot of options, or better, it only does one thing. And so you really are just sort of inserting a feature that maybe you would have written yourself anyway. There are other gems, however, that, like I mentioned, start to overreach their boundaries. I'll pick on devise again. Devise, when you use it, can touch your models, views, and controllers. That's a lot of reach in your code. We actually ran into a situation at Launchpad where we came to a feature that we wanted to accomplish that devise didn't provide for, and we either end up trying to overwrite devise's methods or completely rip it out, which we ended up doing and rolling a different authentication library. Last, and certainly not least, is the value proposition. I would ask yourself, could this feature grow and evolve to become core to our business or our product? Then it might be worth building it in-house, so you get to own that later, and that has a lot of value. For instance, a feature that might collect, manage, and analyze data that you later provide in an API to your customers, all of a sudden that original feature is very valuable. On the flip side, if that's maybe not the case, or you're going down the buy route and you're doing your due diligence, there's a lot of ways to find evidence of a gem's value. You can look at social proof, such as stars and downloads on GitHub and Ruby gems, or you can look at how well it's maintained, documented, tested. There's a lot of ways to kind of figure out, even among different gems, which ones the community finds more valuable and which might be the most valuable for your app. Those are the factors I wanted to cover today, so I encourage you the next time you're faced with building a new feature, you kind of approach it as an executive would, as a build or buy decision, and think critically about some of these factors that could help you decide which route to go. Again, my name is Ifat. Feel free to reach out to me. I'm happy to talk about this more with you guys. Thank you for your time.